Good day, everyone. Welcome to another episode of my YouTube lesson. In today's video, we are going to be discussing about the problem that we have under the equilibrium of forces. So before that, equilibrium of forces is defined as the resultant or the net force and couple that are acting on a body. And this couple, whenever they are acting on a body, they must be equal to zero. And then if you want to approach any question based on this equilibrium of forces, the moment it must be equal to force multiplied by the distance, and also the sum of the anti-clockwise direction must be equal to the clockwise direction. That is the clockwise and the anti-clockwise direction. So also you need to take note of these. So of this, that is the pivot. That is the point of the rotation. This point, you need to take note of this point of the rotation. So let's take a look of this first question. They said that in the diagram above, what is the value of the W? This is our W here. The W was placed at the center of G. This is center of gravity. So from this place to this place is 1. So if we continue to this place is also 1. So altogether from this place to this place will be equal to 2. So it will be 2 meter. So for this W to move to the point of the pivot here, is going to move at a distance of 2 meter. So remember that upward force must be equal to the downward force, or the clockwise must also be equal to anti-clockwise. So this point, you come to this place, like this, and this one you also come to this place like this. So we can just say that the anti-clockwise will be equal to clockwise. I can see upward force will be equal to downward force in some cases if you have many choices of forces in the question. So here we are going to have 20 Newton. You have 20 Newton here. It's acting upward. So 20 multiplied by the 2. Multiplied by 1 here. We know from this point to this point, the distance that we take 20 to get to this point of the pivot is 1. So we 20 multiplied by 1. So this W, so we don't have any force here again. Adding when we have force here, we can still continue adding the force, any force that we have here, we are still going to continue adding it, but we don't have any force there again. So we now move to the other side, which is the clockwise direction from this point. So this is we have one force here, which is one weight here, which is W here that we have here. For the distance that we now take this W to get to this point of pivot is 2. So we now say we're going to write W multiplied by 2. So if you make the W as the formula, we are going to have 20 multiplied by 1 divided by 2. So our weight, which is the W, is going to be 20 divided by 2, which is equal to 10 Newton. So this is how I'm going to approach it. Let's take a look of another question. So we have another question here. They say that a uniform beam PQ, this is P, this is Q, of mass 20 kg. The beam is 20 kg and the length is 5 meter, is balanced as shown below. A man of weight 800 Newton stand at the point of M. This is the point of M, and if someone should stand on this point of on this particular ruler here, the weight of that particular person will be acting downward at M, such that QM from this place to this place, which is QM, will be equal to 2. The next step is to find the reaction at the point P and Q. So this is how we are going to go with this question. So we are given 200 Newton, a man of weight 800 Newton start at the point M. So this man here, the weight of this particular man will be acting downward, which is 800 Newton. So they said that a uniform beam PQ of mass 20 kg. So this is the mass of the ruler, which is 20 kg. So anytime you are given mass of a ruler, if you are doing any question pertaining to equilibrium of forces, you are going to place the mass of that particular ruler to the center of the ruler. If you have a ruler that is 50, you are going to place it at 25. If you have a ruler of 100, you are going to place it at 50. Here now, I have a ruler of 5 meter long now, so I'm going to place it at 2.5. So I can just extend from this place down to this place. I can just say this is the point 2.5 here. I can move it down like this, and then I have 20 kg. So I will multiply it by 2 because this one is in Newton, so I have to let this one to also be in Newton. So after that, from this place to this place is 2.5 meter. So this place now will be 3 meter. The remaining length from this place to this place here now is going to be 3 meter. So you assume that this place is the point of the rotation. This place also is the point of the rotation, like the one we first did the other time. So our upward force here that we have here, they are our point of rotation. So we have P that they asked you to find here and the Q that they asked you to find here. And don't forget that the anti-clockwise direction will also be equal to clockwise direction. And if you want to calculate any moment of the forces, you're going to, any moment of force, you're going to multiply it by the distance that will take them to get to the point of the pivot. So now, they said we should calculate for P and Q. Okay, let's first calculate for P now. So this is we want to calculate for the P. This is our point of the rotation, the point of the rotation, which is Q here. I want to calculate for the P. So I will read from this place to this side now until I get to this place. So the entire ruler is 5. So we have P multiplied by 5 because the distance that will take P to walk to Q is 5 meter. So you get it? And if you notice, I don't have any other force here up here again. So I will now say, okay, let me first write it. That is clockwise. So I don't have any other force here that we up here again. So I will now go along with the forces that I have down here. I have 200, I have 800. So this one is standing at this point of 800, but the distance that we take 800 to get to this point of Q is 2 meters. So I will now say 800 multiplied by 2. We still have another force here down that is acting downward. That is the weight of the ruler. I will add it together with 200 plus, 200 multiplied by 2.5. If you take it 2.5. 200 multiplied by 2.5. So I will now have P5 will be equal to 800 multiplied by 2, and will give me 1,000, I think 1,600. So give me 1,600. 1,600 plus, it will give us 1,600. 1,600 plus 200 multiplied by 2.5, it will give us 500. So 1,600 plus 500 will give us 2,100. We have P5 equal to, so divide the both side by 5 here. So the reaction at P is going to be 2,100 divided by 5. So it's going to be 420 Newton. That is for the P side. So let's calculate for the Q. So this is our point of the rotation now. So we are going to move from this Q here to this point now. So Q multiplied by 5 because it's going to take Q 5 meter. You want to take 5 meter for Q to get to this point. So Q equal to 5 meter. Multiply by 5 meters. So we don't have any other force up here again. So the other force that we have here, they will now act in this direction. They will act in this direction. So we are going to have 200. So we are going to have 800 multiplied by 3 plus. So this one from this place to this place, no, from this place to this place is 2.5. So this place also will also be 2.5. So we are going to have 200 multiplied by 2.5. So 800 multiplied by 3, it give me 2,400 plus 200 multiplied by 2.5 is going to give us 500. So we are going to have Q5 here. So 2,400 plus 500 is going to give me 2,900 to be equal to Q5. So 2,900 divided by 5 is going to give me, so Q will be equal to 2,900 divided by 5. So Q is going to give me 580 Newton. So this is how you are going to approach all this kind of question anytime you are doing equilibrium of forces. So please, if you are new to my YouTube channel, if you find this thing interesting, please kindly help me to subscribe to my YouTube channel, and in order for you to know when I post another video. Thank you.